Okay, so now we're going to continue on here. And so what we were talking about in the last video is that we picked up on the fact that the limit as x approaches 0 of x over sine of x is also just 1. Alright, so now looking at this limit here, I see that this is again very close to the limit as x approaches 0 of sine of x over 5x. But let's not forget what we need to do first. Before we proceed, we need to plug in 0 into this function. And so sine of 0 is 0, and then 5 times 0 is 0. So I have 0 over 0 again when I plug in. Okay, and so that's indicating to me that I need to do some sort of algebraic manipulation. I need to use some trig identities or important trig limits. And so, again, like I was saying to you guys, this looks very close to the important identity here, that the limit as x approaches 0 of sine of x over x equals 1. So it looks very close to that, right? But there's this, 5 here. Okay, so normally, in part A, we had 5 that was, in the input here, but we have the 5 in the denominator. And so I can't really do anything to change the input, right? So now you're like, well, what should I do? Because I can't multiply or something to change the input of sine. Well, here's what's hidden, okay? Because what really is this? Well, this is just the limit as x approaches 0 of 1/5 times sine of x over x. And I hope we agree, right? Because if we multiply across, 1 times sine of x, that's just sine of x, and then 5 times x is 5x. Okay, and so now what can we do? Well, you guys might just pick up on this at this point and just say, well, then the answer is just going to be 1/5. Because it's going to be 1/5 times 1, because I have the limit as x approaches 0 of sine of x over x, which is just 1. All right, and so what I'm going to do is, again, use the properties of limits to just sort of solidify what I'm talking about here, because it might not be as obvious to everyone that when I look at this and see, oh, sine of x over x, it's the limit as x approaches 0 of that, that's 1, and so I can do 1/5 times 1. Okay, so using the properties of limits, what can I do? Well, I can pull this 1/5 to the front, and so I have 1/5 times the limit as x approaches 0 of sine of x over x. Okay, so when I pull that 1/5 to the front, I'm multiplying it by whatever my limit is. And so I know that this limit here is 1, and so I get that this is 1/5 times 1, which is 1/5. Okay, so now, looking at something like this, okay, we first want to, again, just plug in 0 over 0, and so what you're going to get is sine of 0 over sine of 0, and sine of 0 is 0, so you really just get 0 over 0. And so now you might be really, stuck, right? Because it's what should we even do with this? I mean, we have, different inputs. We have sine divided by sine. We can't really do anything here. I can't say that this is sine of 4t. I can't do anything like that, or sine of 7/3 t or something like that. I can't do any of those things. So if I want to use this important this important limit, the limit as x approaches 0 of sine of x over x equals 1, how am I going to do that? Well, I feel like I need to add in this case, my t, because I'm saying the variable is t in this example. Alright, so it doesn't really matter in terms of the variable, everything will still hold the same. It's just instead of x's, I have t's. But here I want to somehow add in a t, right? That's kind of what I'm thinking. I need to somehow add in a t. So how can I do that? again, that thing in math where I just want to multiply by 1. And in this case, I'm going to multiply by t over t, because that's how I'm going to add in that t somehow to use this limit. As x approaches 0, sine of x over x equals 1. So what I'm going to do is I'm going to say, okay, well then this is the limit as, t approaches 0. Of t over t times sine of 7t over sine of 3t. Okay, and so I'm not sure if we're completely convinced why this helps us. All right, well, multiplying this through, I can sort of rearrange and say that this is equal to the limit as t approaches 0 of sine of 7t over t times t over sine of 3t. And so let's step back and just make sure that what I did, like, these things are in fact equal. Let's think about this, right? If I multiply across t times t times sine of 7t, that's the same thing as sine of 7t times t, right? So we're good there. Same thing with the denominator. If I do t times sine of 3t, that's the same thing as t times sine of 3t, right? Okay, so how does this help us now? Well, when we look at this thing, like this piece here, we're almost there in terms of my goal, which was to look something like the limit as x approaches 0 of sine of x over x, so I can use that important limit here. So I'm almost there. I just need a 7, right? Somehow I need to, like, get a 7 in there. Okay, what about this one looking at the right? What do I need here? Well, I need a 3. Okay, because then I can use what we did in part B and use the fact that I know that the limit as x approaches 0 of x over sine of x equals 1. And so that looks very similar because if I had a 3t there, then I can use that. It's the same idea where I have 3t over sine of 3t. And I would have that the limit as t approaches 0 of 3t over sine of 3t is equal to 1. So, looking at this here, somehow I'm saying in the red, I need a 7 in the denominator. And then in blue, I'm saying I need a 3 in the numerator. Okay. So, how am I gonna, like, make these things magically appear? Well, I'd love to multiply this by 3/7. But I can't do that, right? That's gonna change the limit, right? That wouldn't, like, be equal to each other if I just magically multiplied this thing by 3/7. So I can't do that. However, I can multiply by 7 over 7 and 3 over 3, right? Because I'm multiplying by 1 when I do that. 7 over 7 is just 1, and then 3 over 3 is just 1. So that's the trick again, is to magically just rewrite 1 somehow so that it works out for us. So I'm going to do that. This is the limit as t approaches 0. And so now I'm multiplying in the 7 over 7 times sine of 7t over t times t over sine of 3t. And so now I'm multiplying by 3 over 3. Okay. And so when I do that, I get the limit as t approaches 0 of 7 sine of 7t all over 7t times 3t all over sine of 3t. Okay, so now what you want to recognize is that using the product of limits property, okay, I can say that this is equal to the limit as t approaches 0 of 7 sine of 7t over 7t times the limit as t approaches 0 of 3t over sine of 3t. Okay, and so this is equal to, now I'm almost done here. I want to say that this is just 1 times 1, except here I have this 7. So what can I do? I can again use the properties of limits to bring this into the front here. So I have this as 7 times the limit as t approaches 0 of sine of 7t over 7t times the limit as t approaches 0 of 3t over sine of 3t. And so now I get that this is just equal to 7 times 1 times 1, which is 7.